Part B of this lesson involves a technique to make differentiation a little bit easier. This technique is going to be called logarithmic differentiation, and it's logarithmic differentiation, and it is used whenever you have cumbersome derivatives. So like lengthy derivatives or derivatives that involve radicals and rational parts. So I'm going to say used for hard derivatives. So let me start with an example of this. Y is equal to x minus 2 squared over the square root of x squared plus 1. And we're going to do this whenever x is not equal to 2. And that's just kind of a qualifier because we don't want to take a derivative at that point. But that's okay. So here's my function. The process is I'm going to take a natural log of the left side and I'm going to take a natural log of the right side before I do anything. So I get this. And on the left side, I'm going to keep it the same, but the right side, I'm going to use the log properties to break this up. This right here, this numerator, will become 2 times the natural log of x minus 2. And the denominator is going to become, this is an exponent of 1/2, so 1/2 natural log of x squared plus 1. So that breaks up the whole thing. Now I'm going to take a derivative of the left side and the right side. The derivative of the left side is a chain rule derivative. I have to do the derivative of y, which is y prime, times the derivative of natural log of something, which is 1 over that something. So y prime times 1 over y equals. Now we're going to do a derivative of this, which is 2 times the derivative of x minus 2 is 1, then 1 over x minus 2 minus 1/2 times the derivative of this is 2x, and then we're going to do 1 over x squared plus 1 because that's the derivative of natural log. So let me clean this up and show you what we have. Y prime over y is equal to 2 over x minus 2 minus these 2's cancel, and I get x over x squared plus 1. If I multiply both the left and the right sides by y, I get y prime is equal to y times 2 over x minus 2 minus x over x squared plus 1. But y was equal to x minus 2 squared over root x squared plus 1. And we are multiplying this by this 2 over x minus 2 minus x over x squared plus 1. If I add all this up with the least common denominator, I'm going to get 2x plus 2 minus x squared plus 2x over x squared plus 1 times x minus 2. And that's going to be times this x minus 2 squared over root x squared plus 1. The x minus 2's will cancel. I can simplify everything in those parentheses to give me just x squared. Well, I have a single x minus 2, so I have x minus 2. Then simplify everything in these parentheses here, and I get x squared plus 2x plus 2, which doesn't factor, divided by, and I have this times this. This is x squared plus 1 to the 1/2 times x squared plus 1 to the 1, which can be summarized as x squared plus 1 to the 3/2. You will get better at this process, but that actually is much, much less error prone than before. This right here is what I would call simplified or factored. And right here, this is what I would kind of consider to be a raw derivative that's not simplified. So the theorem we're going to use, if u is differentiable, or I should say if u is a differentiable function, and differentiable means the derivative exists, differential function of x such that u does not equal 0, then the derivative of the natural log of u is equal to u u prime divided by u. That's the chain rule derivative of the natural log of something. The absolute value itself also doesn't matter, because if u is greater than 0, then we are okay. I mean, if u is greater than 0, I don't even need the absolute value. And if u is less than 0, then the derivative of the natural log of the negative u is equal to the negative u prime divided by that negative u, which is the same as u prime over u. So I don't really need to worry about if it's negative. So let's practice some other examples of just basic differentiation. This is not going to be logarithmic differentiation. It's going to be basic. F of x is equal to natural log of the cosine of x. And the derivative of this, we do the derivative of cosine, which is negative sine of x. And I do the 1 over, which is going to be 1 over cosine. So that becomes, and then that's negative tangent x. Which also means you've actually now found that the integral of tangent of x dx is equal to the negative natural log of the absolute value of the cosine of x. I'm going to pause this for a second. Okay, number 3, I'm going to ask you to locate relative extrema of y is equal to the natural log of x squared plus 2x plus 3. So extrema are where y prime is equal to 0. Well, y prime is the derivative of the inner, which is 2x plus 2, and then derivative of the outer is 1 over, so that puts the 2x squared plus 2x plus 3 in the denominator. And if I factor it, I get 2 times x plus 1 over x squared plus 2x plus 3. And I want to set that equal to 0. And that occurs when x is equal to negative 1. I also want to see if there are any critical values here. But that can't factor. I'm going to check to see if in the quadratic formula if it gives me real numbers or not. So let's do b squared minus 4ac and see if that's going to give me a negative or positive under the radical. B squared is 4 minus 4 times 1 times 3. That's going to be equal to negative 8. So if I take the square root of negative 8, I get a complex number. I don't want to deal with that. I'm just talking about real numbers. So negative 1 would be where I'd put the graph there for my sign test. Greater than negative 1, I'm going to get a positive. Less than negative 1, I'm going to get a negative. So what I can say is this is decreasing, increasing. I'm going to say that negative 1, comma, let's plug that into the original. Negative 1, f of negative 1, which is equal to negative 1, and that would be the natural log of negative 1 squared plus 2, so 1 minus 2 plus 3 is 2, so it's just natural log of 2. And this is a relative min since f prime of x is less than 0 when x is less than negative 1, and f prime of x is greater than 0 when x is greater than negative 1. So your homework is just a lot of practicing these derivatives. I'm going to pause for a second and resume. Let me kind of do some more examples here of ones that you're going to find. So number 4, we're going to take y is equal to ln of x squared, and we're going to find y prime. 2 ways to do this. One of them is actually to just do a chain rule derivative. 2x divided by x squared gives me 2 over x. But the better way is to take this and to rewrite this as y is equal to 2 ln of x, and then to know that this is the same thing as 2 times 1 over x for y prime. So you're always better off simplifying these things before you do anything else. Number 5, I want to do the derivative of the natural log of the sine of x and see if this gets us anything, since the natural log of the cosine of x got us negative tangent. Well, derivative of the sine is cosine, and then 1 over sine, and that gives me cotangent of x. Okay, number 6, We're going to do y is equal to the natural log of x to the 4/5. You could do chain rule on that, or you could rewrite it as 4/5 natural log of x. And if you rewrite it like that, what you get is 4/5 times 1 over x, or y prime is equal to 4 over 5x. These can be really, really, really quick if you let them do that. Now I want to compare that with this one. If I do y is equal to the ln of x raised to the 4/5, that is not the same thing. I have to chain rule that. That gives me y is equal to the derivative of the inner is 1 over x times 4/5 natural log of x to the 4/5 minus 1 is negative 1/5. So if I clean that up, sorry, this is y prime, I would get y prime is equal to 4 over 5x, and then that would be ln of 5 to the 1/5. From this one, let's say y is equal to the natural log of the square root of x minus 2 over x plus 4. I could chain rule that, or I could decide to split this up by saying y is equal to the 1/2 natural log of x minus 2 minus natural log of x plus 4. This is so much easier because then I can say y prime is 1/2 times the derivative of this is 1 over x minus 2. The derivative of that is 1 over x plus 4. If I bring those together and try to simplify it, I get 1/2 times x plus 2 minus x, or x plus 4 minus x plus 2 over x minus 2 times x plus 4, which is the same thing as 1/2 times 6 over x minus 2 times x plus 4. And 1/2 times 6 gives me a 3. So I have 3 over x minus 2, x plus 4. Last problem. I'm going to find the equation of the tangent line at x equals 2 for f of x equals cosine of 2x times the natural log of x cubed. This is going to be a messy one, but cosine of 2x, natural log of x cubed, I know right away that that's the same thing as f of x equals 3 cosine of 2x times natural log of x. So if I want to do this at x equals 2, let's first find f of 2, which is 3 times the cosine of 4 times the natural log of 2. So given that, that's my ordered pair. I know it's a weird ordered pair, but 2, 3 cosine 4 natural log of 2. And then let's figure out f prime. So f prime of x is equal to, remember looking at this for f, so let's pull the 3 out and do a first derivative of the second. So first cosine 2x, derivative of the second is 1 over x, plus second derivative of the first would be 2 times negative sine of 2x. And really not a whole big way to clean that up. If I do f prime of 2, that's 3 times cosine of 4 over 2 plus, actually minus because of this minus sign, minus, then we have 2 ln of 2 right here, and then the sine of 4. So that's not a good one because this is my slope. If I did a point slope form on this, I'd do y minus 3 cosine 4 ln of 2 equals, slope would be 3 times the cosine of 4 over 2 minus 2 ln of 2 sine 4 times x minus 2. And this is actually my point slope form of something this messy. Y minus y1 equals slope times x minus x1. So this would be an exact answer without a calculator. And we're done.